Hello, everybody, and welcome to another episode of BLS Show and Tell with CHAU TRAN. Ciao, welcome to the show.
Thank you. Thanks for having me.
It's an honor to have you here. First time as a GDE, I suppose.
Yes, it is. First time as a GDE. Thank you.
Awesome. It's always good to have you here. And today you're gonna show me and tell me how I need to work with Declarative THREE.js and Angular.
Yep.
Or can we call it Angular 3?
It is Angular 3, but we'll get to that in a second.
Okay. Awesome.
I think the agenda for today is I'm going to show a little slide. And then when we get to the demo, I'm going to switch back to you.
Perfect.
Yep. So I'm going to share my screen. And so we just jump right into it.
Yeah, let's go ahead. And I'm going to, in the meanwhile, check if we're actually live in YouTube. But please feel free to share. And I will give you control over the screen. There we go. And that should be this. And I'm going to put me here, you there, and me out of.
All right. So, ready?
Yeah, go ahead. Feel free.
All right. So, hi, everyone. Today, we're going to be talking about a declarative THREE.js in Angular. This is an experimental project that I've been working on after seeing some of the integrations, very, very nice integration with React and Vue. So in React and Vue ecosystem, they have very nice integration with THREE.js. In Angular, we have a couple, which I will mention in the slide. But I use a different approach than the current implementations out there for THREE.js in Angular. So first, what is THREE.js? So I'm gonna pull up my browser over here. So this is THREE.js website, and THREE.js is a lot of people just refer to THREE.js as a web 3D library, but in fact, it is an abstraction over the WebGL API. So it will render on the WebGL, which is the GPU, from the browser to render 3D and models and a lot of cool stuff. I mean, this is right here. There's one right here. My blowing website. It is a website. Okay, but it is my blowing. Just quick run through it. And this is THREE.js. You can interact with people. You can interact with the website. And again, it is really, really smooth. I'm sharing the screen. It shows a little bit like laggy, but it's really, really smooth. So this is one. And this is another one that is more well-known. This is like a portfolio or a personal website, and it's interactable. And I mean, it's so cool, right? So you can do this with THREE.js, which is again an abstraction over WebGL, allows you to render stuff to the GPU through Canvas. Right, so enough of it. Now I'm going to go back to the slide. So that's THREE.js. Now, why do we need an integration with Angular? Again, as I mentioned, the React ecosystem has one, probably the most popular one. Vue.js has one. And Angular, again, as I mentioned, Angular does have some implementations out there, but it's not very well known or promoted. And I kind of jumped into my own implementation before researching. So, and I did take a different approach than the current implementations out there. So why do we need one in any framework, basically? Because THREE.js code is pretty verbose. So if I look into the samples right here, if I just pick one example, let's just pick this one, and we look at the code, I'll zoom in a little bit. So you see that this from here, from the script, and all the way down to about, I guess, 500 lines of code, 600 lines of code to render this scene right here. Again, it has a lot of like feature that you can pan around, you can rotate around, you can zoom in. It has some kind of physics going on. So there's a lot of things going on, but 600 lines of code with with a lot of for each, a lot of classes like these right here. It's just verbose. And in terms of working with Angular or any other framework, you get used to the declarative approach with a template, and it is more maintainable with a template or with declarative way instead of these. So that is why we need an integration. All right, now let's just switch back to Bram, and we're gonna just use Three.js code directly in Angular. Without this integration first, we're just gonna write a vanilla Three.js code in Angular. So just take it away, Bram.
Just take it away. As simple as that. Okay, let's see. So right here we have an Angular 11.2 app, latest and greatest. It's running here on local host in my browser. And yeah, let's go ahead. I guess we can just get rid of this one.
Yes. And the first, absolutely. All right.
Make sure that this works. Yep. This works.
All right. The first thing that we want to do, Bram, is to install Three. So go ahead and install Three.
So that'll be yarn add, and it's normal dependency, and it's Three.js.
Just Three.
Just Three. There we go.
Yep. And after this is done, let's go ahead and also install the type definition for Three.
Right. And that will probably be a dev dependency, or at least do it in the neat and clean way.
Yep.
Very good. Now, can you briefly explain to the viewers here what your motivation was? Well, I mean, the motivation, one motivation is there's not a declarative UI library for this in Angular, but did you have any other needs, or is it just interest?
No, a personal need, I don't. Even business need, I don't. But one other motivation that really pushed me to make this work is that I want to prove that Angular is not falling behind in terms of these integrations.
Right. Yeah. And from a performance point of view, you managed to get it on par as the React and Vue counterparts?
Yeah.
Nice. Let's quickly restart this thing. And I guess we could have also done the post install.
Right. Yeah, let's go ahead and put in the post install as well. Right now, Three is just a library, a JavaScript library. So the post install doesn't really do anything yet. Just for the viewers, before the stream, I asked B to add a post install script. So this is to help when we bring in the experimental library that I'm working in, so that we have some intelligence.
Awesome. And you sent me a zip file, classic zip file.
Yep, we're going to get to that in a bit.
Okay.
And now what I want you to do is to open the Three.js website. So just go ahead and Google for Three.js.
I'm gonna DuckDuckGo for Three.js, which doesn't roll off the tongue that nicely, but it gets the job done.
DuckDuckGo.
DuckDuckGo ahead, and here we
go. Go ahead and go to the documentation.
Mm-hmm.
Go to create. Oh yeah, right here. Just scroll down on creating a scene. Scroll all the way down. But for anyone who wants to again learn more about Three.js, please go to this documentation. So you see that the code in between the script. Copy everything inside of that. Yep.
Okay, got that here.
All right. Now, in the component, in the Angular app, first, let's open up the styles.css. We're going to make the HTML and the body take up 100% width and 100% height. And we'll remove the margin on the body.
I guess width is already 100%, but let's in any case do it and just margin 0 on
And
both.
I think the width should be viewport width.
Yeah, you're right.
Yep. And now go to the app component dot HTML. Yeah, HTML first. Let's put in the canvas element with a template variable so that we can view child it.
Yep. And what name do you want this thing to have?
It doesn't really matter.
Going for TMPL.
Yep.
So this will be our template.
Yep. Now go ahead and view child to that and use the static as well, static option to true.
Right. View child here. And I guess this is by its name.
Yeah.
And this will be a template ref.
No, it's going to be an element ref.
Element ref.
Yep. And the type will be HTML canvas element.
Perfect.
And set the statics to true so that we can access it in ng on init.
Perfect.
Next step is to inject the ng zone.
Okay, so I'm going to pick up a constructor and then private read-only zone like this.
Yep, ng zone. Yep. Now let's have the ng on init.
Get this one and have my browser write it for me like this. Perfect.
Right, inside of ng on init, let's do this .zone.run outside Angular. And inside of here, just paste what you just have.
Let's see. Yeah, that should be
and
this.
Yep. So we need to import 3. So import star as 3. And the convention of Three.js is to capitalize the 3.
And this will
right. Yeah. So the next thing is on line 21, remove line 21. For the renderer on line 19, we will pass in our template canvas element instead.
Right.
We still have the WebGL renderer constructor, but we pass in this template.native element.
Right here. So this template.native element, and I'm gonna quickly open. I guess it's still tslint. Yep, and set my semicolons to off because I hate them. Oh, there we go. Never semicolons because it's never needed anyway. Oh, anyway, and then here this will start complaining and say, hey, this might be null.
Oh, sorry. It takes in an object. So go ahead and pass in an object, and that will be canvas.
Right, and this will have a tmpl.native element right here.
Yep, and
Perfect.
just save, and now you will have that spinning cube on the screen.
This
is the most basic example of Three.js.
Right.
And you see how many code that you have to write, and also just can you scroll down to the animate function?
Yeah.
So the animate function is just a function that's going to be called by the request animation frame. So it will be called 60 frames per second. And the request animation frame actually returns an ID that you can clean up later.
Mm-hmm.
So if you hover over it, you will see that it returns a number. So now you're going to have to think about, okay, how do I clean up now? And now you have to, if you don't have an integration with Angular and you write the code in vanilla Three.js, you're going to have to like clean up in ng on destroy or something like that.
Yeah. So right now this will probably leak memory at some point or performance.
Yeah. So you see that on line 34 and 35, on each frame, we're going to rotate the x and the y of this cube by 0.01. You can change that number and you'll see that it's actually changed. There we go.
Yeah, this is wild.
Yep.
I could play with this for hours.
Yeah, so that's the Three.js demo. That's just a quick demo, and we're gonna rebuild the same thing with some additional things on top of it with the Angular 3.
Actually, okay, no, there's one. There was a glitch, probably maybe with HMR.
Yeah, because of the line that you say like document.body.append child.
Yeah.
Yeah, because you removed it. So basically, so if you don't pass in a canvas element for the renderer, it will create one itself, and you can add that to the document body later.
Yeah.
But this is more Angular way to actually view child from your template.
Got it. But this is like 35 lines of code for a spinning cube.
Yep. And also, yeah, and the thing that you have to have when you want to work with Three.js is you always have to have a scene that is going to render your stuff. You have to have a camera that's going to have to look at your stuff. And you have a renderer that's actually takes in the scene and the camera and render it. So those 2-3 things you have to have. And then also there's some kind of things like you have to set the size of the renderer. What about on resize? You're going to have like a window resize event listener. All of that is a lot of code.
Yeah.
Right. So now I'm going to go back to my, slides. I'll continue sharing.
Okay, cool. Take it away, and I guess we can put this one out. Yeah, go ahead.
So I was Three.js. I hope that shows people what is three is in like the most basic level, and how verbose it is to write Three.js. Just to make sure that like you can totally fine like with writing vanilla Three.js, but it becomes harder and harder to maintain it. There's a lot of website with vanilla Three.js out there. It's very, very mind-blowing. All right. Next, we're going to introduce Angular 3. Okay, so this
finally
is
there.
It's finally there for 4 years. It's finally been released, Angular 3. All right, however, I'm just kidding. For some reason, as I talked to B-Man about this, like Angular 3, it was never out. So
has a ring to it, right?
Yep. So I just found out there's an inside joke to this one. Angular version, they skip version 3 because of some conflict in the packages. So they go from 2 to 4. There was no Angular 3, and now we have Angular 3. So
thanks, CHAU, for filling the gap here.
And before we go on, I want to mention these a couple of packages out there. So the first one is React 3 Fiber. This is my inspiration. So this is the most popular 3 integration with in the React ecosystem. And I will circle back to React 3 Fiber when we get to the how it works portion of the slide. Then there's Angular template for Three.js. So this one has a pretty popular and very actively maintained as well. There's latest commit, I think 4 days ago. So it's pretty good. And I took a look into that project. And if something that is nice, they have a router integration, which I don't have yet. But the approach that they took is a little bit different than mine.
But this also, means you can animate your routes using Three.js.
You can, based on the route, animate your scene, not the other way around.
Right. Yeah. Okay, that's interesting. So you can click on a link; it will change your routes.
Yeah, it's like you're watching a credit scene. It's just moved to a different perspective.
Very cool. And I guess the benefit there of having it in the route will be that it routes like a state machine, so it will be on refresh. You'll get to the same thing. Interesting.
Yep. And then we have NGX3. NGX3 is, I think, another experimental implementation. The repo is still maintained. The last commit was like more than 10 days ago, but it's still maintained. And it's going with the approach that I'm going with, but not quite not quite the same. So they use components. Angular 3 uses directives only. So we will see later. All right, just want to mention these. And also there's a guy on Twitter named, I don't know how to say his name, but Benoit, Ben. He's working on his own implementation, but it's not open source yet. But he's going to open source in his open for collaboration. So
that's awesome.
I'm really looking forward to it.
I think I saw you and him chatting around back and forth about this quite a bit, right? Over the last few weeks. Yeah.
Yeah.
Cool.
Right. So actually, you know what? Just go to the demo. I'm sorry. Take your screen just for a couple of sentences. All right. So now we're going to start installing Angular 3. So it's going to be yarn add Angular. That's 3 / core. We want the core. Let's put in the control as well. Angular 3 controls. Yep. No, controls with the S. And that's it for now.
Perfect. Let's add these ones.
Yep. So I break up the library into, again, different packages that you only pull in what you need. That's the main point. Because Three.js is a huge library with a lot of classes.
Right. Yeah. And I see it has an unmet peer dependency on component store.
Oh, right. You need component store. I'm sorry. Sorry, Alex.
No need to feel sorry for component store. There's generally good reason to add component store to your apps as far as I'm concerned.
Yes, we're going to need component store.
Yeah, let's just break it off here and grx-component store and run this again.
Hi, Jeff.
Yeah, let's go say hi to everybody. We have Umar here. Hey, man, good to see you. And then we have Will Willis. Will,
hi, Will.
Nice to see you around. Delis Dominguez, my lovely wife. Thanks for joining, always. And Abel La Fuente is here as well. Loves Three.js. Abel, good to see you. And Jeffrey, and I guess Jeffrey just dropping by to say hello and checking out how CHAU does his talk. So he can invite him on Angular Dutch.
I see what you did there, man. Hi, Jeffrey.
It's like some sort of an interview.
Like screening.
Live screening. There you go. Cool. So while this is going, let's also just make sure, and I'm gonna be on the safe side here and restart my dev server here as well. I might just have to wait till this post install is done. And,
is this running? Yeah, there we go.
It's running, yeah. My machine is not happy doing all these things at the same time.
Yeah, probably.
But I think it's coming to an end fairly quickly.
Yeah. On unrelated news, I hope the Angular linker will be stable soon, so we don't have this NGCC things.
I guess we all think about these things often when we're waiting. Yeah. Here we go. Only took 85 seconds. So let's go ahead and restart dev server. But I think it's also good on a live stream that you see that it happens to anybody and that it's not just your machine, your project. This happens. And this will be a big improvement in the DX, if you ask me.
Yep.
Okay, cool. So now we're going to have the Angular 3 package installed. And you said it's all directive?
It is all directive except for one component, and that component is going to be your canvas. So
right.
We need to have a canvas.
Right. Okay. Cool. And maybe for sakes of the repo, what I can do is create a commit right now, and then if we delete stuff, we can see and compare in a commit.
Absolutely. Yeah.
Yeah. Let's do that. Let's go ahead and commit this with initial 3.js implementation. And I'll make sure I'll link the repo up in the description here. But here we are, clean project, installed this.
Right. Yep, and make sure we still have the spinning cube. All right.
There we go.
Yep. So now before we start.
1 second, please. I'm getting a call coming in. And go ahead.
All right, so before we start, can you scroll down a little bit until the animate method? Go ahead and copy live 34 and 35.
34 and 30. Oh, 34 and 35. I got them here.
Just copy it. Yeah, just copy it, and we're gonna save it for later. Now remove everything you have in ng on init. Even remove the ng on init as well.
Let me go ahead and do just that. So we're gonna go ahead and remove this, and even the ng on init, as you suggest.
Actually, remove everything in your app component.
Everything. Just get rid of everything. Implements here. There we go.
Clean and it would be nice if we can have inline template instead of the HTML file.
Okay. 1 second, please.
Yeah, absolutely. Take your time.
We go inline. I love inline templates. And here we go. Hello there. Let's see if this all works.
Yep.
This all works again.
All right.
So perfect.
Okay. The first thing we're going to need is we're going to need a canvas. So everything component directives in Angular 3 is prefixed with NGT. So if you start typing out NGT dash canvas, you will have that. Yep.
And now for those of you that use VS Code, you can do auto import for your templates. And for those of you that don't use WebStorm, now you need to go here in imports, and you need to import, probably write this thing manually and then put it inside here, the imports. But nobody got time for that. So cool. We got entity canvas.
Yep. So remember earlier we have the mesh, right? We have the mesh, which is an object that holds the geometry and the material to display on the scene. So now the next thing is we need an NGT mesh. So in NGT mesh is actually you're gonna have to go import like 3 mesh module because I messed up one of my import. So now it's kind of like there's another directive like exported from the core that has the NGT mesh as the selector. I think I showed you this on Discord, but I'm gonna fix that later. But now you're gonna have to go in the app module and import the 3 mesh module.
This is what like this one.
Yep. All right, now go to that. So now we have the mesh, but we need the geometry and the material. So go ahead and do NGT box geometry.
And import this module, I suppose.
Yep. And outside of the box geometry, import the write out NGT mesh basic material.
And import its module.
Yep. And on the material, there's an input called parameters, and it is an object. And inside this object, let's pass in a color, and let's do a hex number of 00FF00.
Green.
All right, and let's just save that.
Let's save this. Okay, and this all seems like it all compiles. Or doesn't it? I'm gonna quickly open the DevTools here and dock it to the bottom. There we go. Okay, cool. Yeah, this all works as expected. So we have a box.
Yep. So now we want it to spin, right?
Yeah.
So instead of like trying to set up like request animation frame and stuff like that, I expose on the things that can be animated. Basically, here we need to, here it is the mesh. Mesh is an object. So on the mesh, there's an animate ready.
It's going to be an event, an output.
Yep. And let's just call this event whatever you want.
Okay, animate.
Yep, and just pass in event.animate object.
.animate object. Okay, cool. It knows about that, and we're going to create the method here inside this thing.
Yep, so that mesh will be from 3. You can import star, or you can do that. It doesn't really matter to me. But yeah, now remember the 2 lines that you copy. Go ahead and paste them here.
Yep.
And instead of cube, let's do animate object.
Okay, yeah, or call this one cube.
Yeah, I'll call that one cube. And to save, and then you have the spinning cube.
There you go. Okay, this is pretty neat. And okay, let's say bar from the background, but we can probably just paint the background black.
Yep,
Now we
so
have the
let's
same
do that.
thing.
Yeah, let's do that. On line 7 on the canvas, there's a created output. Let's just do event. You don't have to. Let's do event .gl. Oops, we froze. GL.set clear. There's a set clear color, and you can pass in black.
This is pretty awesome. Now, this is exactly the same thing as the demo, so we can compare lines. Is that correct?
Yeah.
Okay, let's get rid of the app component CSS because we don't need this external CSS file. And we're back to like a 20 line component, but looking at this, these are like 5-6 lines. Maybe with the line here, it's like 11 in total. Whereas here, we were doing a whole bunch more. Let's quickly move back to this animate. I'm just curious to see what amount of code we gained. So we don't have to worry about the scene, nor the camera, nor the renderer, and figuring out where it renders. We do this. So this is basically, if I understand it correct, this is replaced by having the NGT canvas. Is that correct?
Correct.
Okay, and then the geometry and the material are the ones that we do here inside this mesh.
Yep.
And the animate functions here.
Yeah.
Super nice. And yeah.
And now, and now the benefit of doing this is now from line 8 to line 11, you can extract a component out of it.
Right. I'm not sure if I have the new refactor option in. I don't think I updated to the latest version.
Oh, okay.
Extract method. No, WebStorm just released a tweet that the latest version, you can say right-click extract component, and it will do that. But your suggestion is this: you can extract this as a component. Is this something you like us to do?
Yeah, let's do that, and let's do that inside of this file as well. Let's do like a SEM file and do it. Yeah.
So this is like cube component, if you will.
Yep, cube component.
App cube.
Yep.
And get rid of this one and this one.
Correct.
And make sure that I import it in the module here, or declare it in the module here. So it's there. Import it from there. And then what we can do in here is go ahead and get rid of this, replace it by AppCube, get rid of the animate method, and this should still work.
Yes.
And it does. Awesome.
Yep.
You're awesome. This is cool.
Yeah. And that's it. Now, before we move on and let's start adding things to this to make it a little bit cooler, I like to take the screen back, and now I'm gonna explain how this works.
Awesome. Yeah, there you go. I'm gonna put this one right here.
All right. So I'm gonna bring over some code over here, and let me increase the font. And of course, I need to experiment something before I went on stream. Is this good enough, or do I need to go a little bit bigger?
I think it looks great. If somebody in the audience thinks it needs to be bigger, please let us know. I think it looks pretty well.
So I do have a RAM example here, which is this mesh, right? And just don't worry about all those things. See, now we have this mesh. The way that it works is it relies really, really heavily on the hierarchy dependency injection in Angular. So we know that from Three.js standpoint, a mesh is going to have a box geometry, a geometry and a material. So how do we pass in these geometry and the material to the mesh declaratively? Like, I mean, on the mesh, I do have the geometry and I do have the material input that you can pass in directly. And you can always have this. and expose this as geometry, and expose this as material. And then you can pass in directly geometry dot, as NGT box geometry,
Right.
right? And then you can pass in geometry dot. Why is it screaming? Box buffer geometry, my bad. And then on the geometry, there's a buffer geometry that you can pass in for the geometry input. And I mean, in some case, this is recommended so you can reuse the geometry.
Right.
So that's one way. But what if I have like a one-off mesh like this? So the way that it works is that if I have these directive inside the mesh, I can, from the mesh, create for this one as the content child, right? This is an ng content, if you look at it. Or from the geometry, I can actually inject the mesh parent.
Right.
So I can go either way. In this case, I query the geometry and the material from the mesh using content child.
Right.
So that's how I check for it. And I can actually get the geometry instance and the material instance and instantiate my mesh. Another way is that I do expose a way that you can pass in a custom ID for this geometry or the mesh or the material that you can put, just like say, hey, box ID, and then you can just use this box ID and pass in that for the mesh. Internally, I have a component store that store all of the instances of the geometries and the materials so that you can reuse them as you need to. Right, so that one. So again, hierarchy dependency injection. I use this a lot. Same thing, because we put the mesh inside the canvas, and on the canvas we have the scene, so that it knows automatically to add this mesh to the scene.
Right.
If you look down here, when you create the mesh, you have to add it to the scene for it to be rendered. So this step is done automatically by rely on the dependency injection of Angular.
Could you for those of us that are not familiar enough with the terminology, I mean, guess canvas is pretty straightforward to understand, and geometry, in my opinion, is just shape. A mesh is what? How would you describe it? Is it a group of shapes with materials, or?
Basically, a mesh is just a group of geometries, like to render. So if you think about it this way, game engine, they render stuff as triangles on the screen, and then they fill it as triangles with textures.
Right.
Right. So here, a mesh is just basically a physical space to hold some geometries that we're going to render on the screen. So here we have a box geometry. Think about what other geometry you have. So you can have like circle, circle geometry. You can have cylinder geometry. All of these different shapes that you can have to actually put in this space of 3D space, which is the mesh. Then the material, what kind of material that you want to apply to this space? It can be somewhat metal looking, or somewhat like wooden looking, or you have some textures like bricks or walls or something like that. Is the material that's going to like surround this 3D space.
Awesome.
So basically, geometry defines the shape of the space. Then the material defines how it looks, how it feels with the material.
Got it.
All right. So that's the first thing. I want to be able to use the dependency injection system of Angular to build this declaratively. Another one is, again, I use component store, but there is a lot of places that needs the state from the component store but it means in an imperative way. So I do expose imperative state instead of reactive state. Sorry, Alex.
I think Alex is already happy that you use component store in general. So
the reason why is that we have this constant animation frame, 60 frames per second, keep running, and then somewhere else you're going to update the state in some form of way. So like the state can the component stores some information that maybe like the animation need. So on the animate object, on the event of the animation ready, I do also expose the render state. So the render state, let's look at it. It has like the size of the canvas that you rendering. It has the actual renderer. It has the camera. It has the scene. It has the mouse. It has the clock that is gonna take for like 60 frames per second. It's gonna take like, what if you need to calculate or rotate something based on the time elapsed, something like that. So I do expose this. But for each frame, we need to have the latest state of any of these. Right. That's why I need to expose the imperative state. So
can you see the imperative state as some sort of snapshot? It will give you the state of what it is at the moment you pass it in somewhere.
Absolutely.
Yeah.
Absolutely. I mean, and also because it is component store that is provided on this canvas component. So now in your cube component that we just extracted, you can just inject the canvas store and like the animation store, and I mean whatever. So if we look into let's see, GitHub.com, Angular 3.
It's even documented, yes. This animation, by the way, on the intro screen blew my mind when I first saw it. It's like, whoa, super nice.
It is. Fun fact, this documentation is built with Dockersaurus, and it is React. So this animations right here is actually React 3.js. However, I built one with Angular 3, which I'm going to show later.
Same one, same animation.
Same animation.
That's awesome.
I hope I have the information listed somewhere. Let's see. Hold on. I want to show this because I guess it's interesting. Yeah, right here. So component store. I utilize component store. So we have 4 stores, which is a canvas store that has the renderer, the camera, the scene, everything related to build that canvas. And then we have the animation store. This is when you say animation ready, it's actually register that animation with the animation store so that when you destroy the component or when you close the browser, the animation store will clean up everything for you. So I call it like participate in the animation loop. And then we have the instance store. As I said, this instance store has the instances of materials, geometries, and the objects as well. It might have more, but I don't know yet. I need to build more demos, run into more scenarios to actually build these stores, what they have to store. Event store, we're going to get into the events in a little bit, Bram, but the way that the events work with these 3D objects is a little bit different than DOM object. Remember, we don't have a DOM here. It's just the canvas and then the objects inside the canvas. So it's a little bit different to handle the events. And it is something through the raycaster. So think of raycaster means think of your mouse is the contact point of some light source to that object.
Sure.
So when you point, so let's say this is an object, when you point your mouse on it, right? And then there's a ray cast. It will cast light on this object and knows that, hey, this object is being cast with light so that you can interact with it. So that's the ray caster. Just, I guess, look up the documentation. So here we go, just default store provided on the NGT canvas, which all children can actually have access to the same instances. So again, another dependency injection thing. For the services, I do have a loop service. Loop service is basically somewhat internal. You probably don't need to. It just like look up the register animation and then run that animation inside the animation loop. But then I do expose the stop method on the animation loop that for some reason you want to call stop. It will stop the animation loop.
Awesome.
All right. So yep, and that's basically how it works. Now I want to go into how I build this at a very high level.
Sure.
So as we know, that Three.js, if you go to documentation, you scroll down from their reference, API reference, you see all of these, like, I guess, classes. These are all classes that Three.js provide. And think about how many code or how much codes that you have to write to wrap all of these with component or directives in Angular.
Did you write all that code, CHAU?
I don't. I write about 20-30% of it, and then I switch to what I call generator. So let's go back to the slide.
Awesome. Yeah, I think there's a few things. One is there's a lot of them, and also the names are terribly long.
Yep. Again, I just walked you through how does this work. Again, dependency injection, content projection, ng content, stuff like that. And again, now the NX workspace generators. So let me pull up, not this one, the list of structure. So this is the structure of the project. Basically, this is the packages that I expose. And there's one I call it Lifesaver, because it's basically a lifesaver when it comes to working on this project. And you can see that we have all of these classes. The core has a lot of classes. It contains all the geometries and all the materials. And then we have loaders. We have post processing. All of these I still need to work on. But the cool thing is, if we look into the packages, if I go to, and you know what, let's do GitHub 1X on this one, because why not? So if we go to core and I go to, let's say, geometries, you see all of this, box buffer geometry, into wireframe geometry, all of these directives and modules is generated, basically generated from schematics that I wrote.
Right.
So
they are probably all super similar.
It's very similar, and I want to keep it as close to the Three.js API as possible, because if you look into this, I say box buffer geometry, and we look at the box buffer box geometry. You see, it is a constructor with 6 arguments,
right?
And if I were to write this manually, I would have to have like 6 inputs, and that's just for box geometry, and it's a lot. Yeah. So I went with an approach called constructor parameters, so that on the object that you're going to pass in an amount of arguments to the constructor, I would expose an R's input, and that applies to all the geometries. And for the materials is a little bit different. So we look at the mesh basic material. On the material, instead of R's, we have parameters. So I have parameters, and let's look at the mesh basic material right here. So it takes in an object instead of a list of arguments. So for the object, if you look into documentation from Three.js, which you will if you work with Three, things that are going to take in a list of arguments for the constructor, use R's. If it takes in a parameters object, use parameters. So that's the convention that I go with. So it's easier to work with. So as you see from the example, for the material, we have parameters and we pass in an object. And it actually will scream at you, even though we don't have the intelligence. I guess the Angular language service is lacking, but if you pass in a number, I guess it takes in a number. If you pass an array like that, it would scream at you that color cannot text in an array.
Yeah, that's awesome. Yeah.
Okay, so it does have some type-stuff, but it does not give you the intelligence that you need.
Right.
So that's the parameters. And on the geometries, it has the R's. So you can just pass in an array of argument. Let's say, so it's going to be width, height, and depth, I think. So for the dimension of this shape.
Yeah.
So you can just pass in like that.
Basically,
without having
XYZ, if you will.
Yep, XYZ, without having to remember width, height, blah, blah, blah. And me as a library author, I don't have to maintain all of these inputs.
Yeah. It's pretty cool. Yeah. We got Nathan in the show here, who was here yesterday. Definitely check out yesterday's episode. Awesome stuff. Ciao. I totally agree. This is super great. And also want to say hi to Evan Payne, who's also a alumni of BLS, if you will. So it's awesome to see you guys all here.
Yep. So thank you. And before I, so that's it. That's it for me. I mean, if you want to learn more about this library, I'm going to put together documentations, which I am trying to do right now. I'm trying to fill out the GitHub, so you have like the people have as much information as needs, even though this is just an experimental. So. Oh, can I have my screen? Can I have my screen back? Because I want to show something.
Of course, my man.
Sorry.
You can always have screen time on BLS.
So so what you're looking at is the Angular 3 repo, which I'm going to serve the demo side. I have a package called demo, which is just an Angular application, which I build a demo as I work on the library.
It's an NX workspace, I assume?
It is. Absolutely, it is.
Very good. Yeah.
And of course, I do have like secondary entry point and stuff like that in here for stuff that makes sense to have a secondary entry point.
Can you quickly open the workspace file? Just take a quick glance at what packages we're looking at. So is core one big package, or is this divided up into their own?
Core is divided up into core materials,
right.
Core geometries,
these
core
are the
meshes
secondary,
and stuff. Yep.
These are those secondary entry points, and you have one core library that you're actually going to publish, which exposes them all into the single package.
So here's one example.
Awesome.
So you can have this, and then this is an example. This is the example from the documentation homepage. So if I look into the package demo app component, let's just uncomment this one and put this one back in. Oops. And save. I go back. There we go.
This is the demo from your homepage. This is awesome. Yeah.
Yep.
Now, can you quickly walk over the components it takes for you to build this? So start out with the canvas.
We have the canvas, and then we have some shadows right here. So we put in some, we set shadow to true. We set some properties on the camera. We set the fog on the scene in the background of the scene. So you see that fog on the back, gray fog on the back. So that's the fog. And then I have some ambient light, point light. We're going to get into light a little bit later with UB. Another point light. And then there's the component of all the balls. And then this is the context shadows. The context shadow is basically a helpers that I'm building a list of helpers. The context shadows is a helper which will give you that plane. So like the bottom there, you see the plane which is receiving the shadows. So think of the floor. So that the context shadow will give you that floor. without you having to remember to build a plane, to have like cast shadow, receive shadow on it. So it has all that for you. All right,
Looks
now
awesome, man.
let's look into the swarm component. It's just an instance mesh. Instance mesh is just like mesh, but it takes in account. So you can have a SAM mesh with 1,000 of them. So that's the mesh. And then they have a sphere, right? The sphere, right? These are spheres, circle, a cloak, whatever you want to call it. So sphere, geometry, and then the material with the color. And that's it.
Yeah. Yeah. So you make these reusable balls into this swarm, and then if you would say one, if you would render it out with one, it'll just
absolutely. So yeah, let's just change this to, I guess, like 5 instead of 150.
Yeah.
You have 5 of them.
Awesome. Yeah, awesome. So you can really do the componentized workflow you're used to with Angular and probably other modern SPA frameworks. And do.
And then let's see if we can have 500. I haven't tested with 500. There we go, 500.
Awesome. Yeah. And it still renders.
Yeah, it runs actually pretty smooth on my end.
Yeah.
So there we go.
Awesome.
Yeah. Now let's just go back to you.
Okay. Now it's showtime for me. Let's get this screen back here. And what am I doing?
All right. Yep. So now the next thing that we might want to do is we might want to add some interaction with this cube. And again, I like the white background, by the way. So just, I guess, remove the online 7. Yep.
Go
and now we want, we want to have some, I guess, interaction. So go ahead and on the online 17. Oh, actually, online 23, go ahead and add like a state called active or hover. Let's do hover first. So hover equals false. Yep. And now on line 17, go ahead and listen for pointer over event. And let's do hover to true. And for pointer out, let's do hover to false.
Yeah, pointer out, hover is false. Okay, great.
Yep. And now on line 19 for the color, instead of that, we do hover, a ternary, and you can pick whatever color you want. So just pick any color.
Awesome. Yeah, this is as simple as it seems. This is very cool.
All right, now let's have another state called active. And let's do a click and toggle that active.
Okay, click is active, is the opposite of active.
And then we're going to, I guess, like make the cube a little bit bigger with the active. So on the mesh, not the box geometry, on the mesh, there's a scale input. And again, another ternary. So active, when it's active, is the scale will take in an array X, Y, and Z. Yep. Okay, so when it's active, you want it to be like 2, 2, 2. So it's double in size. And then default is just 1, 1, 1.
Cool. And then we go here, click it.
Does it work?
No, it does not seem to work. Let's set this one to true here and see if it
actually is bigger.
Yeah, it does work. I think it looks like the click is not registered. Is it click as is?
It is a click. So let me test on my end because it should work. If it's not, it is a bug. I mean, it's experimental.
Yeah, there you go. There you go. I always assume it's me that it doesn't make it work. So let's.
Not necessarily.
It does work with if I change the color. So it looks like the scale is not.
It still work on my end. maybe scale is wrong. No, the scale is actually right, and the click active is right too.
Active is
So
not
not
active.
sure what happened. Actor,
That
you know what?
means-
Can we? Yeah.
Looks like the click is not getting registered. Well,
It's not.
the strange thing is if I set active, if I use the active here to change the color, it does work. So now I can toggle color with my mouse.
Interesting.
Let's do the scale over hover.
It's actually it should work. I don't know why it doesn't.
Classical works on my machine kind of setup. This
It works on my
CHAU.
machine. Works on my machine.
Yeah,
Let me see. Is there anything that I missed?
it's gonna be me probably.
Actually, can we try to have a handler for the click and do a console log?
Sure. And then log out here the event. And then let's just go do and set active to the opposite of not active, right? It does work here. I'm not sure. I might have lost your audio. Oh, I might lost all of CHAU. That's not a good thing. Or I might have lost my connection. Oh, connection seems up. Not sure if people still are around. I hope you all are. Yep, it looks like CHAU froze on me. Let's wait a little second until CHAU comes back, and I'm gonna quickly check in Discord if he is still online. This is all. CHAU is frozen. Thanks for confirming that, Abel. And yep, it looks like he's still online. I think, yeah, he's at least still online in Discord, and I think he'll be back in a sec. Oh yeah, there you go. There he is. Ciao. Ah, no. I had him for a split second. I had it for a split second here. See if this is coming back as expected. And otherwise, this is going to be a very abrupt ending because I have no idea what I'm doing with this library, as you've all seen. I'm going to give it a few seconds more. Let's, in the meanwhile, check if we can figure out what is going on here. This seems, it's interesting that this doesn't work. It all stopped working at the same time. So I guess in terms of synchronizing it all up, we're good. But I would love to continue looking at this. I'm going to quickly check if he reappears. I just suggested CHAU to use another browser. He said that Restream froze on him, which is not good. And but I'm definitely impressed with this library and how easy it is to do this stuff. Now here's a little box. Here's a geometry with the camera. Ciao. Looks like we got you back.
Hi, hello.
Hey, hey. But it's still not very fluent. Okay, be right back, folks.
So does the click event?
I think your camera is still a bit frozen, Ciao.
Hi.
And
Are
then
we back?
magically,
Are we back?
hi,
I guess
hey,
not.
it all works again. Yeah. Yeah, no, you are back. It looks like it works. If we have a huge delay, we're going to break it off here because this is not the best. You think you can hear it? Can we interact? I don't think it is. This is a sad moment. Yeah, I think...
Yeah, this is sad.
Yeah, it's a sad moment. I think we're going to leave it for here. This was a great demo. I'm pretty sure we'll be back with more. And actually, it got me motivated to look into seeing what I can do with this and play around with it a bit more. So thanks, CHAU. Thanks a lot for building this lib. Thanks for showing us around and demoing me through it. I didn't fail that much as I would expect today. I managed to fail a little bit, so that's good. And yeah, I think we're going to leave it here. Thanks, everybody, for tuning in. It was great to have you. And I hope I see you all at the next one. Thank you. Bye-bye.